Road to Olympiad.
Welcome to RTO. Consider the following problem. Find the value of the summation from n is equal to 1 until 128 for n times 128, choose n. For those who may not know, n choose r is defined by n factorial over r factorial times n minus r factorial. In this problem, for sure we are going to play around with the property of the summations as well as the property of n choose r. For these particular problems, we will be presenting one more interesting solutions. Pause the video if you'd like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that 128 choose n is equal to 128 choose 128 minus n. This can be easily proven from the definition of n choose r. With this, generally, we can write n times 128 choose n plus 128 minus n times 128 choose 128 minus n as n times 128 choose n plus 128 minus n times 128 choose n. This is equal to 128 times 128 choose n, where we can split it into the sum of 264 times 128 choose n. By rewriting one of the 128 choose n back into 128 choose 128 minus n, we have 64 times 128 choose n plus 64 times 128 choose 128 minus n. With this result, we have 0 times 128 choose 0 plus 128 times 128 choose 128 is equal to 64 times 128 choose 0 plus 64 times 128 choose 128. Also, we have 1 times 128 choose 1 plus 127 times 128 choose 127 is equal to 64 times 128 choose 1 plus 64 times 128 choose 127. And we have this all the way until 63 times 128 choose 63 plus 65 times 128 choose 65 is equal to 64 times 128 choose 63 plus 64 times 128 choose 65. By summing all these together with 64 times 128 choose 64, we have the sum of 0 times 128 choose 0 until 128 times 128 choose 128, which we can remove the first term as is equal to 0, and the remaining sum is simply equal to the required summations. And this is equal to the sum of 64 times 128 choose 0 until 64 times 128 choose 128. Factorizing the 64, we have this thing, where the sum in the bracket is simply equal to 2 to the power of 128 by the binomial theorem. And since 64 is equal to 2 to the power of 6, we have the summation is equal to 2 to the power of 134. And this marks the end of our first solutions. Now let's look at another interesting solutions. In these solutions, we are going to make use of the binomial expansion of 1 plus x to the power of 128, which is equal to this one. By differentiating the equations, we have the left hand side is equal to 128 times 1 plus x to the power of 127. And the right hand side gives us 128 choose 1 plus 128 choose 2 times 2x until 128 choose 128 times 128x to the power of 127. Here, by the substitutions x is equal to 1, we have the left hand side is equal to 128 times 2 to the power of 127. which is equal to 2 to the power of 7 times 2 to the power of 127, or simply 2 to the power of 134. And the right hand side is equal to 128 choose 1 plus 2 times 128 choose 2 until 128 times 128 choose 128, where this sum on the right hand side is simply equal to the required sum. With this, we have the required sum is equal to 2 to the power of 134, and this marks the end of our second solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.